Let me go for the next topic, which is bars with varying cross section. So let me consider you have three different cross sections here. So which is 1, 2, 3, which is having different area A1, A2, A3, and having different length L1, L2, and L3. All are having only one force, a tensile force or a compressive force, which is acting on the ends. So how to identify what is the change in length for this different varying cross section? It is very simple. What you are going to do is you split this into small pieces. So what I will do, I will split into three portions. Portion one is this one. Identify what is the change in length for portion one alone. So which is PL by AE. So P1, L, so P is constant, L1 by A1, E1. Okay. So if you have varying material also, right? This is E1, this is E2, and this is E3. Different material, right? In this case, if it is a single material, no need to worry. So everything is E. If it is different material, then you can put E1, E2, and E3. So what we do is you split into small pieces. Identify what is you apply the formula del L is equal to PL by AE. Apply that formula. Find out what is the extension for each piece separately. So portion 1, what is your del L1? Portion 2, what is your del L2? And portion 3, what is your del L3? After that, you identify total del L. So total del is addition of all the three. Okay, so all these small pieces, you just add all these. That will be your total extension of your bar. So the problem is similar, but what we do is we are going to split it into small pieces and we are going to solve it. Right? This is the next step. Let me proceed with a problem related to that. Let me consider here. You have a stepped bar shown in figure. It is having two different materials. So material 1 is having an Young's modulus of 2 into 10 power 5 and material 2 is having an Young's modulus of 1 into 10 power 5. So they're asking you to identify what is the extension if there is a pull of around 30 kilonewton, right? And they also given what is the portion if the thickness is around 20 mm. So which means this is in 3D, right? It is like a rectangle. So just I'll put it here. So it is like this, right? So this is like this, and this thickness is 20 mm, right? You have base and thickness. So from that case, you can able to identify what is the area one, and what is your area two, right? Let me proceed. First, let us identify what is my area one and area two. So area one is 40 into 20, right? So which is 800, and area two is 30 into 20, which is 600. So we got both the areas, which is the cross section area. So cross section area is this. Okay. The next step is let us split this into two. So first portion is only this one. So which is having something like this. So this is my first portion. Okay. So you know what is your change in length formula. Change in length is PL by AE. So it's a common formula. So here what are the variation? L is L1, A1 and E1. Okay, you know all the data. So your P is 30 into 10 power 3. So changing in Newton. L is 600 in this case. Okay. And area is 800, which we already identified. And Young's modulus is also given. So Young's modulus for material 1 is 2 into 10 power 5. So which is 2 into 10 power 5. Substitute it, you will getting around 0.1125 mm. So this is my del 1. Similarly, let us identify what is your del L2. Del L2 is again PL2 by A2 E2. So P is same 30 into 10 power 3. L2 is 800 in this case. And A2 is also different, which is 600. We already identified. And E2 is Young's modulus for this is 1 into 10 power 5. Right? So let me substitute that. We're getting around 0.4 mm. So now I got del L1 and del L2. What we do is we will add it. So total del L is addition of these two. So 0.1125 plus zero point 0.4. So the total deflection or total deformation is 0.5125. So this is my total deformation. Let me consider here you have a steel bar, so which is around 2.4 meter long. It is of a circular cross section they mentioned. So they mentioned what is the diameters of this. So the first one is 20 mm, the second one is 12 mm, and the Young's modulus is a constant value. So which means the Young's modulus is same for both materials. So which is 205 gigapascal. So now what we are going to identify is what will be the elongation of the bar if a load of 22 kilonewton is applied. That is my first question. Second question is, if the same volume of material is made into a bar of constant diameter d, the volume is same, we are going to make it as a bar. Bar means a single cross section, right? What will be the elongation for the same load? That is my next question. Okay. So first we will try to solve the first part, then we will proceed. Before going to the first part, let us try to define our unit. So I am going to solve this in Newton and mm. My unit is Newton and mm. In that case, I want to change everything in terms of Newton and mm so that it is convenient for me to solve the problem. Okay, the first thing what I am going to do is in the given data, you have length, right? So since the cross section area is different, I'm going to split it into two different length, which is L1 and L2. So my L1 is 1.2 meter. If I write it in mm, it is 1200 mm. Similarly, L2 is also same. This is also 1200 mm. This is okay. Now let us go for Young's modulus. My Young's modulus is E, which is equal to 205 gigapascal. What is giga? Giga is 10 power.
10 power 9.
Yeah, 10 power 9. Very good. So giga is 10 power 9. What is Pascal? Pascal is Newton per meter square. 1 Pascal is Newton per meter square. Okay. So make sure I want to convert this 1 Newton per meter square to Newton per mm square. So your meter is in denominator, right? So your meter is in denominator. If I convert your meter to millimeter, what I will do, I will be multiplying with 1000. This is 1000. In denominator, you have 1000, but it is 1000 square. So 1000 square is, you know, the 10 power 3 whole square, which is 10 power 6. So since it is in denominator, when I am writing here, it is to be 10 power minus 6. Okay, so converting 1 Newton per meter square into Newton per ohm square, I have to multiply with 10 power minus 6. Otherwise, I can say like this. E is equal to, if it is 1 megapascal, 1 MPa. So 1 megapascal, that is equal to 1 Newton per mm square. 1 megapascal is equal to 1 Newton per mm square. So the easiest way is convert this gigapascal to megapascal so that you can easily solve it. So what is mega? Mega is 10 power 6. Mega is nothing but 10 power 6, which means your E, I can write it as 205 into giga. Giga, I write it 10 power 3 into 10 power 6 Pascal. Okay, Newton per meter square is Pascal, right? Giga I am converting like this. Giga is 10 power 9. 10 power 9 I'm writing as 10 power 3 and 10 power 6, right? So in that case, what I can say, I can write this as 205 into 10 power 3 megapascal. So as we discussed earlier, so before 1 megapascal is 1 Newton per ohm square. This one is nothing but 205 into 10 power 3 Newton per mm square. Okay, so now I will write it here. So you know what is my Young's modulus now. Young's modulus is 205 into 10 power 3 Newton per m square. So this part is over. So next you have force P, which is 22 kilonewton, which I can write as 22 into 10 power 3 Newton. So I converted everything in terms of Newton and mm. So okay. The next step is I want to identify what is my area because my formula will be PL by AE. I need what is my area. So area depends on your diameters. Let us identify what is my area. So let me identify what is A1. So what is A1? A1 is pi by 4 D1 square, which is equal to pi by 4 into 20 square.
314.159.
159. Okay, thank you. Mm square. Similarly, let us identify what is your area 2. Area 2 is pi by 4 D2 square, which is equal to pi by 4 into D2 is 12. So 12 square, 113.097 square. Right? We identified all the values. All the thing is I have to substitute. That's it. Okay, let me consider this as first part and this is my second part. So let us identify what is del L1. Del L1 equal to P L1 by A1E. So your P is 22 into 10 power 3. L is 1200. L1 is 1200. Area 1, we already identified 314.159. So it is 314.159 into Young's modulus. Young's modulus is 205 into 10 power 3. We converted to Newton per ohm square, right? That value. So can you tell me what is your del L1? 0.4099 mm. Thank you. So I identify this value. Then we go for the next one, which is del L2. So del L2 is same. So PL2 by A2E. So which is equal to 22 into 10 power 3 into L2 is also same, which is 1200. So L1 and L2 both are same, divided by area is different. Area is 113.097. 113.097 into, so 205 into 10 power 3. So this is my del L2. So can you tell me what is the value of this del L2? 1.138 mm. Right now, let us identify what is your del L. So del L is addition of this two, del L1 plus del L2. So both adding it, you will get this. This is equal to 0.4099 plus 1.138. So what is your del L? 1.547 mm. So this is my answer for your first subdivision. So this is over. Now let me go for the second subdivision. What is the second subdivision says? So if the same volume is having a constant diameter d and the length is around same, which is 2.4 meter, then what will be the elongation? So for that, what I do, I have to identify what is the volume for this particular right? Then only I can able to identify what is the diameter. Okay, let us take the same thing, same diagram. Let us identify what is the volume. So to identify the volume, right, you can split this in again into two. So the first part and the second part. Okay, the first part we already identified, right? Volume V is equal to, let me call it as V1 plus V2. What is V1? Cross section area into your length, right? You know what is the cross section area, which is already identified, and length is also known. So use that, multiply that two, you will get V1. So which means cross section area for the first one is 314.159. So just substitute 314.159 into your length. Length is 1200 plus cross section area for the second one. The second one is 113.097. 113.097 into its length. The length for that is also 1200. So what is the total volume we are getting? So 512.7 into 10 power 3. So cube. So this is what we are getting. So this is my overall volume. Now volume is same, they mentioned, which means let me consider. So you have a rectangle now. This is my rectangle. And the rectangle length is already known, which is 2.4, which is 2400 mm. Right? Diameter I want to identify. Diameter I want to identify. Volume is same as like your previous one. Right? What is the formula for this? What is the volume formula for this? V is equal to, for this case, so area into length, right? So area is pi by 4 into d square. I don't know what is my d. That's why it is pi by 4 cross section area into length. Length is 2400. So these two volumes are same. In that case, I can relate this. So what is my relation? So pi by 4 d square into 2400 is equal to 512.7 into 10 power 3. So find out what is your diameter here,
Sir,
right?
51.79 வருதுன்னு sir.
51.7.
Yes, sir.
Okay. Okay. So it is 51.7 mm. Yeah, thank you. So now we identified what is our diameter. Okay, so my diameter is 51.7. Right. So I need what is my area. Cross section area for this. இதுக்கு நான் என்ன பண்ண இதை எடுத்துக்கல. So diameter வந்து questionல கேட்கணுன்றதுக்காக we identified diameter is 51.7. But let us consider the same thing here. So இதே equation. இதுல வந்து பாத்தீங்கன்னா you can able to see this part pi by 4 d square is your area. Right? So if I need area, what I have to do? So I have to divide it with respect to that 2400. So I'll get what is the cross section area. Enna cross section area varudhu? Can you tell me?
Sir, D is 16.49, sir.
D yeah.
ஆமா சார்.
Yes sir, 16 point lo sir.
Okay, 16.4.
496.
16.496. Okay. A என்ன சொல்லுங்க? So A வந்து just divided with respect to 2400.
213.625.
213.625. So this is enough. So I got what is my area. So now let us apply. So this is my bar. So my force is same. What is my force? My force P, which is same. So which is in the previous problem, which is 22 kilonewton. So force here is 22 kilonewton. So let us identify what is our deflection del L. So my del L is equal to PL by AE. So where P is 22 into 10 power 3, L is 2400 here, divided by area. So what is the cross section area, which is 213.625 into Young's modulus. So let us look after your Young's modulus. Young's modulus is 205, right? So 205 into 10 power 3 into 205 into 10 power 3. So you know what is, you can identify what is it, del L. So we're getting 1.205. Thank you. 1.205 mm. Right. So we got two del L's now. One is this 1.205. The other one is 1.547. Which is best one?
Second one, sir.
Second one. Very good. So what I'm going to I try to say is, let me consider. So I'm going to imagine, right? Imagine this as a particular application oriented problem. Let me consider a table. You have a table, something like this. Okay. So this table, if the leg of the table is like this, variable cross section, and if the leg of the cable is directly a straight cross section, which one you have to buy?
Straight cross section, sir.
Good, sir.
Or
Second one.
Second one,
Second one, sir.
because it is having lesser deflection. Okay, this is having lesser deflection, which means it will be very good when compared to the first one. Okay, so this is one way to relate your problem in terms of an application. You have a bar which is 1000 mm length. So the diameter of the bar is given, which is 30 mm, and they have made a hole at the center, right? So they have made a hole at the center, which is around 400 mm. So the diameter of the hole is also given, which is 10 mm. It is shown in the figure. So if a load of 30 kilonewton is applied, what happens is you will get an extension of 0.22 mm. In that case, they are asking you what will be the material property. What is your modulus of elasticity for this particular problem? So now you think about it. How many segments you have to split this? So you have to split it into two segments. So the material property is same. Only difference is your cross section area. What happens if I split it here? If I split it here, what happens here is one side, this side is a solid circle. You have a solid circle, whereas this side is a hollow circle. So this is my difference. So one side you have a solid material, the other side is a hollow material. You know all the data related to this. So what are the data you know for a solid material? Right? If I consider this as 1 and this as 2. If I consider 1, so my 1 is just a circle. You know what is the diameter of this circle? So your diameter or radius of this circle is 30. You know that. So in that case, you can easily identify what is the cross section area. So A1 will be equal to pi by 4 into 30 square. You will get this. The second part, if I consider, it is a hollow circle. You have one circle, inside you have another circle. It is something like this. So you know that this circle, so one is having a diameter of 30, other you have a diameter of 10. So you know that both diameter is 10, right? So this is having a diameter of 10. In that case, I will get A2. What will be my A2? It is pi by 4 into external diameter square, 30 square, minus internal diameter square, 10 square. Now, can you able to identify what is the values of this A1 and what is this A2? Can you tell me what is these values? A1 is 706.5 mm square. So it is 628.31 mm square. Now I identified what is my areas for these two, right? For section 1 and section 2. Now, according to the question, you are applying a load of 30 kilonewton, and if you apply a load of this 30 kilonewton, you are getting a deflection, which is 0.222. This deflection is maximum deflection, that is del L, which is nothing but del L1 plus del L2. It is a addition of this del L1 and del L2. So now let us identify one by one. So let me go for section 1 to identify del L1. So what is my del L1? So del L1 is equal to P L1 by A1E. So this is the formula PL by AE. That is my formula. So what is my P? So I am solving everything in Newton and mm. So I am solving in Newton and mm. So convert it accordingly. Your P is 30 kilonewton. So which means 30 into 10 power 3 into L1. So what is the length for this segment? So this is 1000 minus 400. So we'll get 600. 600 is my length of this segment. So it is 600 divided by A1. A1 we already identified 706.5, and E, I don't know what is the value of E. Let me consider like this. Right. So can you solve and tell me what is the value for this with respect to that?
25.47 into 10 power 3.
25.477 into 10 power 3 divided by E is what we are getting. So let me consider this as equation 1. Now let us go for the next section. Let me go for section 2. So section 2 is this part. Section 2 is this part. So you already identify what is the area. So let us identify what is your del L2. Del L2 will be equal to P L2 by A2E. Your Young's modulus is constant, same. So P is same value, which is 30 into 10 power 3. L2, you know, it is 400. So the hole is up to 400 mm. So L2 is 400 divided by A2. So A2 we already identified, which is 628.31. So it is 628.31 into E is my value. So let's identify what is your del L2. 19.09 into 10 power 3 divided by E. Okay, very good. Thank you. So this is my equation 2. Now you know that your del L is equal to del L1 plus del L2. So you know what is your del L, which is total change in length. Total change in length is 0.222. So I will substitute it. So 0.222 is equal to del L1, which is 25.477 into 10 power 3 plus del L2, 19.09 into 10 power 3 whole divided. E is a common term. That's why I am dividing this. L divided by E. Just cross multiply. So you will get E is equal to this entire term. Right. So what you are getting?
200.79 into 10 power 3.
0.79 into 10 power 3 Newton per mm square. So whenever you consider low carbon steel or mild steel, your Young's modulus E is 2.1 into 10 power 5. This is my Young's modulus for low carbon or mild steel. It is nearer to that, so which means this will be a low carbon steel. Okay, so sometimes they won't give E value. They will say that it's a mild steel. If they say it is a mild steel, then you can consider E as 2 into 10 power 5. 2 into 10 power 5 Newton per mm square. Okay. Yeah. So you have a tensile load of 40 kilonewton, which is acting on this diameter. So you have a rod of diameter 40 mm. 40 kilonewton force is acting. So the length of the rod is around 4 meter. So what they are saying is, if they make a hole of 20 mm at the center of this rod, what will be the length you have to make a hole so that you will get a 30% increase in its extension. Right. So to solve this problem, first I have to know what will be the extension for this particular rod. Then what I have to do, I have to identify what is the increase in extension. Then I have to proceed one by one. So it is a combination of two problems which is connected like this. So let me consider the first case. So case one is this particular diagram. So I'm going to consider this diagram. So what are the values? So it's you have something like this. I will take this picture. No problem. I will take this picture. I will put it here. So you know what is the diameter of this? So your diameter D is 40 mm. Your length of this rod is 4000 mm. I am converting everything in mm. And force P, which is applied here, is 40 into 10 power 3 Newton. So since these values are known, let us identify what is the area. So area A. So area A is pi by 4 into 40 square. So what will be the value we are getting? So pi by 4 into 40 square. Yeah, we are getting 1256.63 mm square. So this is the value for our area. Now what I will do is I will identify what is our change in length for this problem. So let us identify what is the change in length. Change in length. Change in length, you know the formula, it is PL by AE. Applying this. So P is 40 into 10 power 3. L is 4000. Area is we identified 1256.63 into Young's modulus. It is also given. It is 2 into 10 power 5. So 2 into 10 power 5. So when you substitute it, what is the value we are getting here? So del L 0.6366 mm. This is my change in length. Now what they are saying is, if I make a hole for this particular rod, you are getting an extension of 30% increase in your extension. So your extension is 30% increased. You consider that this as a GST, something like a GST. So you are getting a T-shirt for 100 rupees. If they put a GST as 30%, how many money you will pay? 130. So how you are identifying that 130?
Add 30% of 100, sir.
Yeah, so it is 100% plus 30% of 100, right? So 100% is your original value plus 30% of the 100, right? So this is the thing we are going to identify. For example, if it is in this case, what I'll say, I can write it as 1.3, right? So this is nothing but 1.3. So 100 plus 30 by 100 is 1.3. So which means if I want to pay 100 rupees, you multiply with 1.3, you'll get 130. So that is what I am paying. Similarly, here there is an increase of 30%. So I know what is my del L, which is 0.636. So if there is a 30% increase in del L, 30% increase in del L. In that case, it is nothing but del L is equal to 0.6366 into 1.3. What will be the change in length in this case?
0.8275, sir.
0.8275 mm. So this is my new change in length. So this is applicable when you make a hole for a particular length. Okay. So now let us go for case 2. So case 2. So board with a particular diameter. So this is my figure. Now what the thing is, if I consider a particular hole, let me consider you have another rectangle here. So it is bored to a particular distance. Okay, so you can able to see that this is two different cross sections, right? So one is a pure solid cross section. The other one is with a hollow cross section. So for the first one, you already know what is the area. So A1, which we already identified. So which is for 40 mm diameter. So 40 mm diameter is 1256.633. So this is 1256.633. So this is my cross section area for segment 1. So for section 2, you have two diameters now, right? So one you have 40 mm diameter, other which is a hole which is center, right? So what is the hole size? So hole is 20 mm, right? So this is 20 mm. So one is diameter 40, other one is diameter 20. In that case, I can identify what is my A2. So my A2 will be equal to pi by 4 into 40 square minus 20 square. So what will be the value of my A2? So 942.4. So you're getting 942.47 mm. Right? So this is my data. So the question is, what is the length? So what is the length? I have to make it as a whole. I don't know what is my length. Okay, but I know what is the total length. My total length is 4000. It's already identified. In that case, I can able to identify this length. So what will be this length? It is like 4000 minus L. So because I don't know this length, right? So this will be 4000 minus L. This is my L1. What is my L1? So I will write it here. So my L1 is 4000 minus L. So L2 here is nothing but L, right? So we'll go for each section one by one. First, section 1. Let us identify what is del L1. Del L1 is P L1 by A1E. What is my P? So P is 40 kilonewton. So which is 40 into 10 power 3 into L1. So L1 is 4000 minus L divided by A1. So A1 we already know, which is 1256.633. 1256.633 into E. So E is also known, which is 2 into 10 power 5. So except this 4000 minus L. So whatever the thing we solve. So I am just considering only these terms. I'm going to just solve these things. You're getting around 1.5915 into 10 power minus 4 into 4000 minus L. Let me proceed with the next section, section 2. Section 2 is del L2, which is equal to PL2 by A2E. So P is again 40 into 10 power 3. L2 is L here. A2 is different, which is 942.47. 942.47 into E. So E is 2 into 10 power 5. So what is your del L2? So all the terms except L, 2.122 into 10 power minus 4 L. Thank you. So this is my del L2. Now I know. So I know that del L is equal to del L1 plus del L2. So del L is the 30% increase, which we already identified. So we identified del L 30% increase is 0.8275. This 0.8275 is equal to del L1, which is 1.5915, 1.5915 into 10 power minus 4 into 4000 minus L plus 2.122 into 10 power minus 4 L. So can you solve this? You have only one unknown term, which is L. So can you solve and tell me what is the value of this L? Okay,
3598.49.
35.49. Okay. So it is approximately around 3600. Right? So I can say that it is approximately 3600 mm. So which means I have to make a hole of around 3600 mm in order to get the 30% increase in my change in length. Okay. Right. So this completes our problem.